Hi, welcome. In this video, we're going to talk about compiling C++ files. So let's get started. We're going to go over and review the steps in the compilation process. Then we're going to talk about how to split programs into multiple files and talk a little bit about makefiles. So let's get started. So let's review the process, how your IDE takes your source code, which would be like hello.cpp, and converts it into an application or an executable. So let's review the steps that happen. You have your word processor. Again, this is an IDE, so everything is included in it. You have a plain text file, which has a .cpp extension. Then the compiler goes through that and makes sure that you don't have any syntax errors. So an IDE is more than just compiling. And it also is going to check all of your includes during the compilation process. And when it converts the source code into assembly, part of that is going to make sure that you don't have any syntax errors like spelling errors or missing semicolons. So if it gets through all of that, it's going to turn it into an object file. Then you have an object file which have a .o extension. And then if you have more than one object file, they're going to get linked together and turn into an application or an executable. So the files get combined into an executable or an application, and then you run that on your computer. So what is an object file? So the object file is all of the machine code that was taken from your source code file. So your source code file gets turned into an object, but it needs to be linked in order to execute. So we're going to talk a little bit about how you can create object. Your IDE does all of this automatically. When you run, when you go to run, it compiles and builds and links. But we're going to talk a little bit how you can do this not in the online compiler, but in VS Code or in Ubuntu or through the terminal. You can, with commands, compile and link your objects together. So we're going to talk about that in this presentation. All right, so first we're going to talk about the concept of multi-file programs. So why would you break down programs into multiple files? Well, it makes them more modular, and we haven't covered classes yet, but you usually separate your classes into the implementation part of your class and the declaration part of your class. Now we're going to just separate our functions into our prototypes or declarations for our functions and our function implementation. You also can collaborate on teams. So the components of a multi-file program is you will have a .h, and then you will have your .cpp. So each, you might have more than one .cpp, you might have more than one .h, and you're going to have a .cpp that has the main function, and that is sometimes called the driver. So that would be the driver program, the one that's going to connect everything together, because like I said before, if you have int main here in a program, this is where you start execution. So execution is going to start at the very first instruction in the main program. So you're going to have a CPP file with your main function. So some examples you could have that I'm going to go over in this presentation. We have sayhello.h and sayhello.cpp and main.cpp. And our main is usually going to be last name and then whatever assignment we're on .cpp, because this is a class. So you're going to not name your main file main, you're going to name it with your last name. We're not going to do a lot of separate compilation in this class, probably just 2 of your projects, because it's a lot more, it's a lot of work to grade, but I do want you to be exposed to it. So we're going to do one now, and then we'll do another multi-file program when we get to classes, and we'll break our classes into .h and .cpp files. We're going to be breaking our functions in our program. We're going to have a function.h that's going to have our declarations or our prototypes in it. So our functions.cpp is going to have the implementation or the function definitions. And the way that we're going to do it in this class is we're going to have our main.cpp, which will be our last name, whatever assignment, A3, A4, whatever assignment we're on, and this will call the functions. You can also call functions from here, so we might do a little bit of that as well. All right, so here's an example for a hello world. So we have the name of we're calling this is, this should be .h, say hello .h. So this has our function declaration in it. And then say hello.ppp says to include, this would be the name of the file, would be say hello.h. And so the .cpp says include say hello.h. And then this is the implementation of our function definition. So this is our declaration or prototype. This is our definition. And then this would be our main, which also you need to include say hello.h. And here is where we are calling the function right here. So this is separating and making our programs more modular. Here's another thing about header files. So in the header files, just review, is where you have your prototypes. Also, if we're going to include any structs or anything, which we're not going to do in this assignment, but we will be doing that. Here is an example of a header file for functions.h. This is not the function we're going to use, but this is a function. Now this part right here is just saying that I don't want to have a multiple files called functions.h. So I'm defining this if it hasn't been defined, and then this is the end of the definition of function.h. There's a modern way to do it. You can just put this at the top of your program, at the top of your .h file, but not all compilers use it. It's a modern. So my recommendation is to do it this way, and this is the way that I've given you the template. So this would be in your .h file at the top. You just include this at the top, you're defining, and this should all be capital letters. And then this is the end of the definition. And then in between here, you will put your function prototypes. And then in your implementation file, you just say, I need to include functions.h. And then if you need to include anything else like standard stdio.h, stdio, IOStream. I'm thinking about C. So in C++, you would include IOStream here, or you would, and using namespace standard, or you might also need to include string. But in this case, we're not doing any input or output, so it's just a function that adds things together. And then the main, of course, is going to include IOStream and include functions.h. And it's we didn't put using namespace standard, so you have to use the std with the scope resolution operator. But if you put here using namespace std, then you don't need to put std with the scope resolution operator also here. And that should be, it's been cut off. All right, so let's talk a little bit more about just C style of programming. In the C style of programming, you use meaningful variable names, identifiers for your data. Indentation is not required, but indentation should, your blocks of code should all be indented, and the more you practice and you look at examples, you will see the style of the code and how C, look at examples of how C code should be structured. Also, your IDE, if you type in an instruction and then you put a semicolon here at the end and you hit enter, it will help you to align your code. When you put an opening curly brace and a closing curly brace, all of this should be indented. And so I do put a lot of examples, so please take a look at them. I also give you templates for your assignments. and your code should be consistent. And sometimes white space matters, sometimes it doesn't. It matters in strings, but it doesn't matter in space between lines of code. And sometimes it's nice to space things out to make them, to make it look nice. You should also include comments. It's very important to put comments on your function prototypes. I should be able to look at a prototype and know how to use that function and read the comment and understand what it does. You should also include them on your definitions. You should also include a header comment. That's very important, with your name, date, and a brief description. The brief description would not be like assignment 3. The brief description would be describe what the program does. You should also put comments when things are not obvious in the code, and there's nothing wrong with putting extra comments while you're learning. And of course, it takes experience to have comments, and I already said you should have a descriptive header comment. All right, so how do you do multiple files in the online compiler? Well, again, you're not going to create the object files or anything. Everything is done for you. It is a complete IDE. So all you do is you just select new file and you name the files. So in this case, we're going to have functions.h, functions.cpp, and then you're going to have your other file, which will be last name. I think we're on assignment 3 or whatever assignment we're on, .cpp. So that's where your main is. Your main is going to be in your in that, and it can be called main, but then when you submit it, you copy and paste it into Notepad or whatever text editor you're using. You would save it with your last name underscore A3. So here's how you do it. You just go up here, there's a little icon, and you click new file. Then you put the name of the file, and you will see then you have extra files. So here I have my main.cpp, I have my functions.h, and I have my functions.cpp, and you just tab over then. So right here I'm in my main.cpp, and then here I'm in my functions.h, and here I'm in my functions.cpp. So it's very easy to add files and do this on the online compiler, and that's actually what I'm going to demonstrate for you when I go over your assignment. But some of you are using Linux, so we're going to go over that, and we're also going to go a little bit over VS Code. All right, so we're going to talk a little bit about using the G++ or GCC compiler and how you compile and execute with the GCC compiler. So if you are using terminal in a Linux-based system or VS Code, you can type in and use the GCC or G++ compiler. All right, so the process is you compile to an object file. So this is the command. You type in G++. This is the name of your file, and this is I wanted this object, and this is the name of my executable. So this is the command to compile using terminal or VS Code. So I think that we've already covered this in the earlier module, but we're just reviewing because we're going to go over how to do it with multiple files. All right, to execute, this is the command to execute. You just type this in, and then it will run the program. All right, so let's do a little bit more about the Unix system. So Bash is a shell and a command line interface used in Unix-based operating systems. Linux and Mac are both Unix-based operating system. It stands for Born Again Shell. So it is the default shell in many operating systems. The terminal is a command line interface, so it's just a terminal, and it allows you to interact with using text-based commands. So you can practice. I'm not requiring it for this semester, but we are hoping that students will be interested to work in Ubuntu and use Terminal to work on their C++ programs and do some, so we can also do some exercises with Linux systems programming. I am covering it in this class this semester, and it will be covered in the lab in future classes. All right. So these are just features. You can, you have a lot of control to manage your files and everything using the terminal and the commands. So there are some utilities, ls to list your files, cd to change directories. So this will be covered, like I said before, in the lab, but this is just an overview so that we are at least giving you some coverage of this material in this class. You will not be assessed on it in this course this semester. All right, so here's what it looks like. So if you're in Ubuntu, you can type in cd and you navigate to the directory. So I have a folder, COP3275C, assignment 1. I have a source file in here, so I can navigate. This is how I'm navigating through Terminal. This is what it looks like in the window. So then I can type in the command. The name of the source file is sorgenteprog1.cpp. So this just means generic source file. Program is the name of the executable. So if I type in this, I can compile, and I'm creating an executable that I'm naming. I'm naming the executable program. And then to execute it, I just type in this command right here. You can see where it's typed in on this line, where I first spelled it wrong, and then I typed it in right there, and it executes the program. And this is what the source code looked like here. So it's going to execute, this right here is going to execute the program Hello World and print Hello World onto the screen. All right, so how would you do multiple files? So we're not doing classes yet, but we will cover this again when we get to classes. So this is without classes. So if you have main.cpp and functions.cpp and functions.h, you should put them in the same directory, and then you can compile them. So this is to compile without linking. So this would create, this is one at a time. So we're going to do one at a time here. This would be to compile and create an object file of main. This is to compile and create an object file of functions. And then you can link them together and create an executable. So this, I want to use the compiler to take my object file main, my object file functions, link them together, and this is my executable. And then I just use the same command to run that executable. This is the command to run that executable. So here's another example. This is an example just doing it in, I have my this source code file right here. I also have my functions.cpp right here, and I have my functions.h. I created fun.o and main.o, and then I'm going to do the command to link them together and create the executable. Now, if you are in this directory, of course I have to be in the right directory. So if you notice here, I've navigated to that directory. So if you are in that directory and you have more than one CPP in that directory, you can compile them in one command like this. So I'm just demonstrating, what you can do to do it separately like this and create object files, or you can compile it like this and create one executable. But once I do that, I can then, this is the linking step, and then I'm creating my executable, which I have now created my executable. Or like I said before, I could have just done it all like this. Now, why am I going over this? Because you want to have control of what you're doing. You want to understand, part of this is not just doing and robotically going through the motions, it's understand what's going on, understanding what object files are, understanding the process of going from source code to an executable. When you do it in an IDE, you just do it in one step. When you do it through the terminal and you create your object files and then you link them, you're actually step by step going through the motions. So that's, it's very good to understand how that works. So this is just another screenshot of it. All right, so another thing that you can do is you can make what's called makefiles. And makefiles help you to automate compilation so you don't have to type in the commands. You run a script and then the script does everything for you. So this is a very good way to organize large projects. So I want to go over, that the process to do this. Again, we will not have any assessments on this. We will not be doing this because we're not enforcing everyone use the Linux system or Ubuntu this semester, but I still want to go over it. All right, so this just is good for large projects. It handles everything, puts everything together. It's very efficient. You can make rules about how you want things to be compiled, and it also ensures that everyone is using the same process to build their applications or executables. So this is the information that is going to be in a makefile. And just some things about here I wanted to go over. Some of this you've already seen, like G++, that's compiling. This is an object. Create object files. This right here means compile only. Again, if you add the debugger, you want to compile so that you can debug your code. So those steps are also separated. Like I said before, when you do an IDE, you are just doing, everything's done for you, but it won't compile and build if there are errors along the way. So it does give you feedback when you're using an IDE. Here you just have a lot more control and you're giving the commands what you want to do. All right, so this is just an explanation of what's going on. We already know these are the dependencies. These are the object files that are needed to build your program. This is the command to link everything together. Each object is compiled here, compile only, and the clean removes any compiled files. So this is just an example of some syntax that would be used. It's just all put into one file, and you can also use variables. So for example, this would be a variable for G++. This would be a variable. So everywhere that you have this right here would be replaced with G++. Everywhere you have this right here is the object, which is these object files that you have. So you can use variables to make it cleaner and obviously to reuse things so you don't have to type it in again. So this right here would be, that's what this right here, you just replace that. If you see here, this part right here is the G++. The flags is, this means warnings, and then compile only, and this main.cpp, and this, so this whole command right here using the variables that looks a little strange is going to generate main.o. But you can use these same commands right here, but you can use variables obviously for things that you're going to use more than once. How do you run a makefile? You just you can use a shell script, and then you can automate things and run them. So why would you use makefiles? Because they automate compilation and you compile only files that have changed. You can control the flags in your compilation. You can clean and build the directory, and it gives you a lot of control. So it gives you a lot of control to put large projects together. The whole idea of all of this is that you take larger projects and you break them into separate files. But then, as you can see, by going through all the commands of compiling each file and building these and building objects and linking things together and all of that, if you have 3 files, it's not that big a deal. But if you have a lot of files, it's a really big deal and it's a big project. Then you use Makefiles so that you can automate all of the compilation and linking and creating your applications. So Makefiles is a way to do this, and it gives developers a lot of control. This is just an example of how to do multiple files in VS Code. So if you are using VS Code, you need to make sure that you have your files are here. I have my 3 files there, and then you just use the same commands that you use in Terminal. You can compile them all together like this, and as long as you don't have any errors or any problems in your code, then you can create your executable, and then you can run your executable. So I'm not sure if people are using VS Code, but if you are using VS Code, it also gives you a lot of control. And so we are trying to get students to have some exposure, or to at least have seen both, Linux and Ubuntu terminal and VS Code with C++ programming. So at least you've been exposed to some of it. But at the same time, we have to spend a lot of time learning how to program. So this takes a lot of time to master these tools. And so our focus right now has been just learning C++ basics. And the easiest and best way to learn C++ basics is to use a online compiler or a complete IDE that does, that kind of hides all of these steps and just gives you some good feedback with the debugger to help you to get your code correct. Thank you.